3x cubed times negative 4x plus 3y. 3x cubed times negative 4x plus 3y. So in this case, we're multiplying a monomial, a single term, by a binomial, two terms. Now, is it super important that you know that vocabulary? Not super important. I just use those terms, so I'll try and use them as much as I possibly can. Y'all know what to do, right? You distribute the 3x cubed. Let's review some things with multiplying. When you multiply your coefficients. So 3 times negative 4 is, of course, negative 12. When you multiply like bases, you add your exponents. Okay, you add your exponents. So that x right there didn't have an exponent, so it's understood to be 1. 3 plus 1 is 4. So that's negative 12x to the 4. So no big deal on that one. Then we've got 3 times 3 is positive 9. Now on this one, we've got different variables. Since we have different variables, there's no combining that we can do. If they are not the same base, you just got to write it as x cubed times y. And that is all you can do on this problem, because now we don't have like terms, right? We've got x to the 4th here and we've got x cubed y. They aren't like terms, so this is all we've got. Okay, next one, we are multiplying a binomial times a binomial. Now, I do not care which method you use, whichever method you learned, whether you learned FOIL or box or whatever, I don't care which one you use. Me personally, in this class, I'm going to use FOIL. So I'm going to multiply my first two terms. 4x times negative x is negative 4x squared. I'm going to multiply my outside two terms. 4 times negative 3 is negative 12. X times y, I just got to write that as xy. Then I multiply my inside two terms. Negative y times negative x is positive xy. Always try and list them in alphabetical order as much as possible. And then when I multiply my last two terms, negative times a negative is a positive 3. Y times y is y squared. Now we do have some like terms here. We've got negative 12xy plus xy, so we can combine to get negative 11xy plus 3y squared. Okay. Now, since I mentioned the box, I will show you over here really quickly for a refresher. If you know that you liked that method, but you may have just forgot some of the details of it, the order doesn't matter. I typically put the first one on the top and the second one down the side. The reason why the box works, and part of the reason why I'm bringing it up is because we're actually going to use this idea here in just a minute, is because what this is representing is it's saying, okay, if the length of this part is 4x and the length of this part is negative x, the area is length times width. So you multiply these two terms together. 4x times negative x is negative 4x squared. Then for this box, you multiply the negative y times the negative x, so that gives you positive xy. This box, you multiply the 4x and the negative 3y, so negative 12xy. And then the bottom box, negative y times negative 3y, so positive 3y squared. And then you would add your like terms there in the middle, and you get the exact same result. Okay, so if you like FOIL, do FOIL. If you like the box, do the box. I don't care as long as you get the right answer without copying your neighbor's paper. Okay, another one like this, 3b minus 2 squared. What trips people up with this is they just want to square everything that's inside the parentheses. But what squaring something truly means is that you multiply it times itself. So 3b minus 2 squared is really the same as 3b minus 2 times 3b minus 2. And then it's a problem just like we just did. FOIL it out. 3b times 3b is 9b squared. 3b times negative 2 is negative 6b. Negative 2 times 3b is negative 6b. Negative 2 times negative 2 is positive 4. Be careful with those signs. They can be tricky. And then we've got negative 6b and negative 6b combined to give us negative 12b plus 4. And that's our final answer. Okay. Let's do one that's very similar to that, but just a slight difference. Our binomials look almost exactly the same, but one has a minus and one has a plus. So let's multiply that out. 3p squared times 3p squared. 3 times 3 is 9. P squared times p squared is p to the 4th. Multiplying is the only way your exponents change. When we multiply the outside, 3 times 2 is 6. When we multiply the inside, we have negative 2 times 3, so we have negative 6p squared. And then when we multiply our last, negative 2 times positive 2 is negative 4. Look at what happens. Positive 6p squared minus 6p squared, those cancel. So all we're left with is 9p to the 4th minus 4. Now, if you think back to some factoring real quick, this is the difference of perfect squares. If you remember the difference of perfect squares, your factors always look exactly the same except one has a minus and one has a plus. So you may not have ever factored perfect squares with a variable to the 4th power, but it is the difference of perfect squares. Okay? Any questions on those 4 examples right there? Okay, that's mostly a review. Let's flip over to the back. Okay, let's flip over to the back. This is new. This is new. Let's look at the first problem. A rectangle has a height of x plus 4 and a width of x squared plus 3x plus 2. Express the area of the entire rectangle. I kind of already went over this just a second ago. Area of a rectangle is length times width, right? Length times width. So technically you can go over here and you just say, okay, or in this case, height instead of length. X plus 4 times x squared plus 3x plus 2. Well, you might know how to handle that. You might not. That's why we've got this area model right here to help us out. Okay, this is like the box, but instead of having 2 terms times 2 terms, we've got 2 terms times 3 terms. So if you like the box, here's the box with a binomial times a trinomial. Okay, so x times x squared is x cubed. X times 3x is 3x squared. X times 2 is 2x. For the bottom row, 4 times x squared is 4x squared. 4 times 3x is 12x. And 4 times 2 is 8. So I wrote those expressions in those boxes on purpose because that is the area of that. It looks like a square, but it's really a rectangle. X times x squared. X cubed is the area of that blue square right there. 3x squared is the area of this red rectangle right here, because we took the height times the width and we got the area. Then we just need to combine like terms. I'm going to add these up. So we've got x cubed. We've got 4x squared plus 3x squared, so that's 7x squared. And then we've got 12x plus 2x, so that's 14x. and our 8 is hanging out there by himself. So that is the area of that entire rectangle. If you add up all the tiny rectangles, you get the whole rectangle. Okay. So that's one way to get the answer. Let's go back up here real quick. Okay. If you don't like the box, if you would rather just do a FOIL-like method, let's look up here at the top. You're going to distribute the x to all the terms in the second set of parentheses. X times x squared is x cubed. X times 3x is 3x squared. X times 2 is 2x. Are these numbers looking familiar? Okay, they were the exact same numbers that we just got on the first row of our box method there. Then we distribute the 4 to everything. So 4x squared, 4 times 3x is 12x, 4 times 2 is 8. Exact same numbers we just got when we did kind of the box method there. Either way, we come to the same conclusion, x cubed plus 7x squared plus 14x plus 8. Okay, so I'm giving you a little choice here. Whichever one makes more sense to you, whichever one you like to do better, run with it. Okay. All right, let's do a couple more examples of this, and then I'll let you practice some. X minus 3 times x squared plus 3x plus 9. Me, personally, I don't really care for the box. I'm just going to do the distributing. So x times x squared is x cubed. X times 3x is 3x squared. X times 9 is 9x. Then we distribute a negative 3. Negative 3x squared, negative 9x, negative 27. Combine like terms. X cubed, standing alone. 3x squared minus 3x squared, gone. 9x minus 9x, gone. Negative 27 left there on the end. So don't get totally freaked out that our answer looks so much different than the first example we just did. It is possible for all those terms to cancel and we only get the cubed term and the constant term. You're not always going to end up with 4 terms when you multiply binomial times trinomial. Most of the time you will, but not all the time. The next example there is just to show you that the order of multiplication doesn't matter. It doesn't matter whether the binomial is first or whether the trinomial is first. We're going to get the same result. If it really bothers you that the trinomial is first, just move it to the end or move the binomial to the beginning and handle it the same way. I'm going to do it this way. I'm just going to distribute from the back. 5x times negative 3x squared, negative 15x cubed. 5x times 2x, 10x squared. 5x times 7, 35x. 7 times negative 3x squared, negative 21x squared. 7 times 2x, 14x. 7 times 7, 49. Just so that you multiply each term by each term, you've got your bases covered. Doesn't matter if it's flipped around. So we've got negative 15x cubed, 10x minus 21x. That's a negative 11x squared. I think I said x instead of x squared. 35x plus 14x plus 49x, and then plus 49. If you want to set up a box, you can set up a box. There's nothing stopping you from doing that. If you would rather do it that way, or if you want to do it the way that I just showed you, as long as you can do it consistently,